Today we are going to study about Gauss law. Gauss law states that Gauss law states that electric flux electric flux through any closed surface is equal to electric flux through any closed surface is equal to 1 by epsilon 0 times the net charge enclosed by the surface. Gauss law states that electric flux through any closed surface is equal to 1 by epsilon 0 times the net charge enclosed by the surface. That is, flux phi E is equal to 1 by epsilon 0 Q enclosed. Phi E is equal to 1 by epsilon 0 Q enclosed. Next, we can move on to the proof of Gauss law. Suppose we have a point charge plus Q and we need to find the electric flux through a closed Gaussian spherical surface or spherical Gaussian surface. Suppose this is the spherical surface and we have a plus Q charge here. We need to find the electric flux through this surface. So we have the radius of the surface as R, and electric field of a plus Q charge will be radially outward, and area vector is also in this direction. So we have phi is equal to EA cos theta, and theta is the angle between E and A. So electric field is radially outward and area vector is also outward normal. So the theta is equal to 0 degree and phi is equal to EA, which is equal to electric field into area of that sphere. Electric field due to a point charge at a distance r is equal to kq by r square, and area of a sphere is equal to 4 pi r square. So we can substitute for k is equal to 1 by 4 pi epsilon 0 q by r square into 4 pi r square. 4 pi cut, r square cut. So flux is equal to 1 by epsilon 0 q. So this is Gauss law. This is Gauss law, and note the electric flux from this equation. It is very clear that the electric flux is independent of the shape of the surface. The electric flux here, electric flux here is independent independent of shape of the closed surface. That is, in this equation it is very clear that flux depends only on net charge enclosed and epsilon 0. So flux is independent of shape of the closed surface. And second point, charges inside the surface will contribute to the electric flux and charges outside will not contribute to the flux. That is, only charges inside the closed surface will contribute to the flux. That is, charges outside will not contribute to the flux. Contribute to the flux. That is, We have a closed surface like this. It doesn't matter what is the shape, and we have charges Q1, Q2, Q3 inside and Q4 outside the surface. What will be the flux? Flux is equal to 1 by epsilon 0 times net charge enclosed. Net charge enclosed. So phi is equal to 1 by epsilon 0 Q1 plus Q2 plus Q3. Q4 will not contribute to the flux, right? And next, we can do a problem. Suppose we have a bowl of hemisphere. We have a hemispherical bowl and we have a point charge at the middle of this bowl. What is the flux through the bowl? What is the flux through the bowl? So we know that electric field due to any closed surface is equal to 1 by epsilon 0 times net charge enclosed. So we have a hemispherical bowl. We will assume that it is a sphere, that is, it's a closed sphere. If it is a closed sphere, flux through that sphere will be 1 by epsilon 0 q enclosed. Since it is a hemisphere, the flux through the hemisphere will be 1 by 2 times 1 by epsilon 0 q. So this is the flux through this hemisphere. Similarly, suppose we have a cube, suppose we have a cube like this, and we have a charge q on this face. We have charge q on this face. What will be the flux through the cube? What will be the flux through the cube? So we can do one thing. We can add one more cube like this. We can add one more cube like this here, so that the charge is completely inside a closed shape. So that the charge is completely inside a closed shape. Then the flux phi through the surface will be 1 by epsilon 0 q net. Since we need two spheres or we need two cubes to completely enclose the charge, we can say that the flux through the flux through one cube is equal to 1 by 2 times 1 by epsilon 0 q net, right? So next question, suppose we have a cube like this, suppose we have a cube like this, and we have one point charge at one corner of the cube. What is the flux through cube and what is the flux through one of the face? So first we will do that. First we will enclose this charge by placing similar cube around it. So to completely enclose this charge, we need four cubes. One cube this side, one cube this side, one cube on the top, one cube on this point. So we need four cubes to completely enclose the charge. So flux through, if we enclose the charge completely with adding four more cubes, the flux will be 1 by epsilon 0 times q net. But here the flux is phi is equal to 1 by 4 into 1 by epsilon 0 times q net, and this is the flux through 1 cube, and flux through phase is, we have 6 phases for a cube, therefore flux through one phase is 1 by 6 into 1 by 4 into 1 by epsilon 0 cube, which is equal to 1 by 24 times q by epsilon 0.